Now, AC generator and transformer. AC generator is the device that converts mechanical energy into alternating current. Its principle is based on electromagnetic induction. When a closed coil rotated in uniform magnetic field. With its axis perpendicular to the magnetic field. So the magnetic flux linked with the coil changes and hence an induced EMF is obtained. This is the concept. I have already discussed that this kind of induced EMF can be obtained by three cases. What are those? By changing the flux, by changing the area, by changing the theta. Okay. So here we are changing the orientation, rotating. What about the motional EMF? We change the area by moving the rod. And the D5, that where we discuss about the magnetic induction. By using the two coils or single coil, we are changing. So with the help of also that magnetic flux change results in induced EMF. Now we have come to the last part. Right. Let me consider the magnetic field moving in this direction. I have kept a coil like this, and here, let me consider this part. Okay, so this is the magnetic field direction V, and it's a perpendicular is that is this one. Are you able to follow? That is this one is perpendicular for this, and it makes an angle theta. This is the n cap that makes an angle theta. Do you understand what I mean? Now listen to me. Let me have the coil like this. Okay. Now the magnetic field is going this way, right? It moves. I have put four fingers like this. So likewise, magnetic field goes. Now I have put the coil. So the connection is it goes like this coil, rectangular coil, and comes here and go back. This is the coil again. Now I am considering the perpendicular. Are you able to understand this? Okay. So perpendicular means this one. Clear? This is the perpendicular. So perpendicular, let me put a smaller one. So this is the perpendicular. Are you able to follow? Okay. So for the coil perpendicular is this is n cap. And let me twist the plane like this. Are you able to understand? Now this is the perpendicular. Are you able to follow? This is the perpendicular to the coil. Okay. So here, this perpendicular n cap. Okay. And what about the magnetic field line? It goes like this. Okay. So in that case, what is the angle between the normal to the plane of the coil and the direction of the field? Do you understand this? Get me one flashcard. Sir, one small pencil is there. Do you have any smaller one? Small pencil. Don't you have any small pencil? Okay, right. So this is the perpendicular n cap. This is the coil. See, coil goes like this. Here, here, here. Okay. So perpendicular the coil means I can put here. So this is the perpendicular to the plane of the coil. Do you understand this? And what about the magnetic field? The magnetic fields are going in this direction. This is on magnetic field lines. Are you able to follow? So let me consider one blue line, magnetic field. Okay, so the field line is not changing. It goes like this only. Now listen to me carefully. I have fixed at certain angle like this. This is the plane of the curve. Now I am close. Are you able to understand this? Okay. So I am slightly tilting. Are you able to understand this? Now the angle between the perpendicular of the coil, normal of the coil, normal to the coil. Okay. What is normal to the coil? This black pen. Do you understand? So this is the plane is twisting like this in this position. This is the orientation of the coil. And here the magnetic field. So the angle between the black pen and the blue pen. The blue pen represents what? Magnetic field. Now slightly let me tilt. Are you able to see the angle? That is theta. Black sketch is the normal to the what? The coil. You have to consider, and that is why they put n cap. What do you mean by n cap? The perpendicular. Okay, so the perpendicular to the coil, the plane surface here. Now listen to me very carefully. If it is like this, see this? Now this perpendicular is also perpendicular to the field line. Okay. Now when the coil turns like this, what happens? It is almost aligned with the magnetic field. Now what is the angle now? Zero. What is the angle here? 90. Do you understand this point? First of all, okay. Audible follow. So this is theta. Let me say theta. So theta is 90 degree. Now I am turning like this. Theta is less than 90 degree. Is it true? And now theta has become zero. Horrible follow. Do you understand this? So here zero, it is in between, it is 90 degree. Clear? So the coil is going to rotate like this. Got it? The coil is between the magnet and north pole, south pole. So from north pole to south pole, the magnetic field lines are moving. So this is the setup. Now let me explain one by one. See, you know very well, magnetic flux take down. I hope now you should be able to understand the cap. So I have put like this in this way, and this is the magnetic field line. Do you understand the diagram now? See that I kept like this. Okay, is it clear? So the black is normal to the plane of the coil, but it has got an angle to the field, magnetic field. Okay, right. So that is theta. You should not get confused, sir. You have said here perpendicular, then you put theta also. I said it is not the, most of the people they are mistaken that. It is the angle between the coil and the magnetic field. That is wrong. It is the perpendicular to the coil. That is very important. Okay, what is that? It is the perpendicular to the coil and the magnetic field line. Okay, so that is called theta. And that is why I put here particularly this end cap. Now let us consider. So the theory part let us discuss. You consider a coil, take down. It consists of n number of turns of coil in n number of insulated copper. Rotating in the uniform magnetic field. It is rotating. It is rotating means along with the field and so this is the coil. Are you able to understand? This is the incoming line. It goes like this, like this, like this, like this, and comes back. This is the coil setup. It is going to rotate. Are you able to follow? So forget about this. You have got only one more thing here. Let me have this one, the small one. Do you understand? So this is the normal. Now the normal is in this direction. It is perpendicular to the perpendicular is perpendicular to the magnetic field lines. You hear, listen here, watch here. Okay, the perpendicular is what? It is a perpendicular to the magnetic field. Now it is twisting. Now the perpendicular to the plane is having some angle theta. Are you able to follow theta? Then it is aligned with the magnetic field. So likewise it is rotated. So what happens here? Theta takes various positions. I'll explain one by one later. Now this coil of n turns of insulated copper coil. Okay. Next one. The magnetic field is B. The angle between, listen to me very carefully, the angle between the, what is theta? Angle, take down, angle between the magnetic field lines and area vector. Okay, area vector is that normal at an instant because that coil is rotating like this at any instant. So at an instant is theta. So the coil is rotating at a speed of omega. This is the angular velocity of the coil. So the magnetic flux is given by how many number of turns of coil? N number of turns of coil. It depends on what? B, the magnetic field, and also area enveloped by the coil. A, area enclosed by the coil. Do you understand? Then cos theta. Okay. And you know very well, theta is, what is omega? Angular velocity theta by t. So theta can be replaced by omega, right? So you can replace this. What is that? N, B, A, cos. Instead of theta, you can put omega t as a whole. Now listen, in this case, we want to write this in terms of sin omega. Okay. So what we have to do, we have got only phi, and now we are going to what? Differentiate with respect to time, right? Differentiate with respect to time. So this is phi. Take down. Now what do you mean by induced EMF? It is nothing but rate of change of phi. Is it not? Minus d phi by dt. Got it? So that is equal to minus d by dt of, you have to substitute the entire equation here. Okay. What is that? N b, instead of phi you can put this a, and then cos omega t. Okay. Let us go step by step. Now listen to me carefully. So which are the constant here? Tell me. N b a, right? We can take outside the bracket of differentiation. Therefore, induced EMF is equal to minus NBA into d by dt of, what is that? Cos omega t. Okay, got it? Is that clear? Now, what is a cos omega t on differentiation? It becomes what? Minus of sin omega t. Okay, so minus NBA, and omega, it comes in the front, minus omega into sine omega t. Do you understand this? So minus of minus plus, therefore NVA, and then omega, then sine omega t. Do you understand now? So this is the induced EMF. Okay. Now let us draw a plot. It is a sine wave. From this, it is called, this is a sine function. It is clear that this is a sine function. So for the sine function, we know the maximum can be 1, right? Are you able to follow? We are studying in trigonometry. Okay. So in the y-axis, it can go up to 1. So it means the maximum can be when sine omega t is equal to 1, the E can be maximum. We can call it E naught. So it means when sine omega t is equal to 1, okay, then what happens? The En becomes what? The induced EMF becomes, that is, this one becomes E naught. As I already, E naught is maximum. We can call it E naught. E is maximum, maximum, and that is indicated by E naught. Are you able to understand? So that's what this. Okay. Therefore, we can represent this equation as, that is, E is equal to E naught sine omega t as a sine wave. Okay. Now what happens when, you know very well, omega t is nothing but what? Theta. Okay. When sine omega t is equal to 0, what do you understand from this? Theta is equal to 0. When theta becomes a 0, when it is the perpendicular aligns with the, this is the, are you able to follow? Okay. So most of the students, they mistaken that, sir, plane is vertical. How can you say it is angle zero? I hope now you should be able to understand. So the plane may be zero. The plane vector is perpendicular. And that plane vector perpendicular line is matching with the, that is why. So it means what? Sine zero becomes what? No current. Sine zero means a zero. When it is like this, 90, it achieves the maximum peak. Horrible follow. And that is why you are able to get the alternating current with the maximum, minimum, maximum, minimum, maximum. Minimum. I hope now you should be able to understand. Okay. So this is a very important concept and you should be able to understand the diagram also. Okay. In your book, they would have given very nicely about the diagram. You kindly go through that and I will continue in the next class. Okay.